We saw numerically and graphically how this limit as we approach 3 from above went to positive infinity, and this limit as we approach 3 from below went to negative infinity. I do want to quickly state in this video the idea or the concept of the epsilon delta definition of approaching infinity. So we say that the limit of f of x as x approaches value c is infinity, denoted limit x approaches c of f of x equals infinity, means that given any number n greater than 0, there exists a delta such that for all x in the interval where x is not c, if x minus c in absolute value is less than delta, then our output is greater than n. How you should read this is basically, once you get close enough to c, our values become really, really big. And by values, I mean the output values become really, really big. So if our input values are really, really close to c, then our output values become really, really big as I ever want them. We are not going to deal with the epsilon delta definition of limits going to infinity, but I at least wanted to present that because it is different than the epsilon delta definition of the limit, because we don't have any epsilon greater than 0. We have some large number greater than 0, and we're saying the outputs just keep getting bigger than that large number for sufficiently close inputs. I did this limit as x goes to c, but you could have also amended this pretty easily to be x goes to c from the left and x goes to c from the right. So you could have done the plus or the minus in the exponent there. And then you just force x to be greater than c or x to be less than c, depending on whether you're approaching from the right or approaching from the left. Similarly, if we have a limit going to negative infinity as x approaches c, then that means there is a sufficiently small n such that for every delta greater than 0, there exists a delta greater than 0 such that for all x in the interval where x isn't c, if the x value and the value c are really close, meaning smaller than delta, then the output value is going to be really, really small. And so you just pick a really, I call it a large negative number, a negative number whose absolute value is large. And you can find a function which is smaller than that negative number. Just like positive infinity, you can amend this pretty easily to approach from a single side. Now, with all that being said, most of the time, we're going to use other techniques for finding limits which go to infinity. So what I would like you to do is try this problem, or I should say these two problems. Find the following limits using either a numerical or a graphical approach.